All right, this is example 9.6 that's in your book and also that is in the presentation of the PowerPoint. I want to do it a different way and just show you you don't have to go some of these rules because we had different things where it's government or industry. If you do it sort of ways, different ways will give you should be giving the same answer in the case. And this one gives you the same answer as before. So first of all, let's look at we're going to do the delta BC ratio, and we're going to start off with the right-hand turn versus the do-nothing turn. In other words, whether we want to do the right or not. And what we actually talked about is you put different values up for B and also for benefits and for the cost. One way is just to do this. Just put purely all the benefits that you actually have up on one thing for the benefits and all the costs below and the bottom. So what we have is that we only have one benefit, and that's the $1.6 million that we actually have, and that is actually the present. We're going to have this annual savings that we're going to have. So we're going to move that all back to the present. So we're going to find a P given an A at 10% and for 15 years. Now that is the only benefit that we actually have. The next one we have is the costs that are actually associated with it. The cost is for the building for 9.8 million. Then you have some the 0.9, which I believe is referred to as a disbenefit that actually occurs. So that's just a cost to to impede the people. Then you have the maintenance, which is occurring every year that you have. So that one is, we're going to say 0.15 million, and we're going to turn that into a P given an A again at 10% for 15 years. So when we actually have this one, we come up with a ratio of 12.17 million to 10.94 million, which comes up with a ratio of 1.1, which is greater than 1, which means that doing the right-hand turns is better than just leaving it as it is. So in this case, right wins in this term. Now what we can do is move on and do a comparison with the idea of doing the left-hand turns. So the left-hand turns is definitely more costly, and so we have the right versus the left minus the right. And what we have is that we have the benefits. Again, we only have one benefit for the left, which is a 2.2 million savings. We're going to find a P given an A, and we're going to be 10%, and that is for 15 years. And we're going to subtract off the 12.17 million that we got already in the previous calculation for the benefits that we actually had there. We're going to go on and continue the costs. There is the cost associated 3 million and 1.2 million for this benefit, and then the maintenance costs, which are 0.075 or $75,000 a year. So we have to find a P given an A at 10%, 15, and we'll subtract off the cost associated with the other one, which is 10.94 million. And so what we actually come up with, we come up with a ratio of 4.56 million versus in benefits versus the 4.77 million in cost, which comes out to be 0.96, which is not greater than 1, which means it is not worth the investment to create the left-hand turns but to keep the right-hand turns. So right wins again and is final selection. So this is just a different way, and it's a little bit more straightforward, where you actually just put all the benefits on one line and all the costs on the other line and just let it go, and it should give you the same answer as the other two methodologies that we talked about in 9.6. All right?